different metal ions and ligand donors also changing. Under such conditions, it will do only the function of the particular enzyme. So, as hemoglobin, the iron is present in the plus 2 oxidation state in the deoxy form, that won't give any information about the spectral properties. That is the reason why the porphyrin core is giving strong intense absorption band in the UV and visible region, but whereas in the case of the iron orient, iron centered transitions are not observed in the visible region. Iron is in the plus 2 oxidation, which is symmetry as well as spin forward in transition. So you won't observe any much intense band in the UV visible region. So for that we are using the cobalt analogous of some of the ligands. These ligands are most to mimic the, this is a planar ligand which is having 2 nitrogen and 2 hydroxyl group. In the case of the porphyrin, we have a planar porphyrin ring structure with along with the N2O2 coordination. So N2O2 coordination. So when we are making a cobalt complex, this cobalt complex and they have studied the O2 binding ability of this cobalt 2 complex. This cobalt 2 complex can be reversibly bound with the O2, and after a certain stage, what would happen? There is a dimeric bis mu cobalt 2 complexes or cobalt 3 complexes are. So beauty about the synthetic system is synthetic system we can change the solvent. By changing the solvent, we can tune the properties and the functions also. But the enzymes will can handle the enzymes only in the aqueous environment. But there is no such restriction for your metal complexes. Metal complexes that we can make it in the organic solvent and we can do the study and we can observe the spectral changes. That is user friendly, somewhat user friendly, but it is its stability is concerned. Biological systems are highly stable. These molecules are only stable for in some only, not in all environments. That's the main thing. So another one synthetic oxygen complex which is do the reversible water binding is a Vascas iridium complex. It is nothing but iridium chloride, iridium monochloro monocarbonyl, bis triphenyl phosphine complex. The triphenyl phosphine is arranged in a trans manner, whereas if the 2 triphenyl phosphines are in the trans manner, automatically the carbon monoxide is also trans to the chlorine only, and the binding with the Vascas iridium complexes is taking place in the oxidative manner. The oxidative addition, what is oxidative addition? What is the result of oxidative addition reaction? Have you ever heard? Oxidative addition என்னதுப்பா? யாருக்கா தெரியுமா? தெரியாதுன்னா சொல்லுங்க. சொன்னாதான் நமக்கு தெரியும். What is oxidative addition? Oxidative addition recognition கேள்விப்பட்டிருக்கீங்களா? கேள்விப்படலையா? என்ன வரலையாப்பா? Anybody?
No sir.
இப்போ metal complexes வரும்போது வந்து நம்ம வந்து oxidative elimination two kind of reactions பார்ப்போம். The oxidative addition is the reaction in which upon the oxidative addition of the ligand, the coordination number increases by 2 units and the oxidation number also increases by 2 units. If the metal is in the plus 1 oxidation state, at the end of the reaction, the product will be in the plus 3 oxidation state. The starting complex is in the 4 coordinate geometry and the product complex will be in the 6 coordinate geometry. It may be a square planar, the product may be a octahedral arrangement. That is the oxidative addition. Reductive elimination is the reverse of the oxidative addition reaction. And during the reductive elimination, the oxidation number decreases by 2 units as well as the coordination number also decreases by 2 units. That is the reaction. That is the reductive elimination. Reduction of the metal side followed by the elimination of the 2 ligands from the coordination in sphere will take place. Whereas in the case of the oxidative addition, oxidatively addition added means the oxidation state also changing. There is a from lower oxidation state to higher oxidation state and coordination number also increases. How many units it is increases? It is increases by 2 units. So automatically O2 addition is reversible. Here also the Vascas iridium complex can undergo reversible O2 addition reaction. This is the complex which is having iridium in the +1 oxidation state with a 16 electron complex. So it is not stable. Whenever oxygen is binding, it can be converted into and electron complex. This is the first synthetic reversible oxygen carrier. This can be, with respect to the environment, it can bind and release the molecular oxygen. This is Vaska's iridium complex. The IR spectroscopy of this Vaska's iridium complex also recorded. This is the Vaska's complex is observing around 2010 centimeter inverse. When oxygenated, there is a slight change in the band position is observed. That is a 1960, approximately 50 centimeter inverse. There is a decrease in the stretching frequency. IR stretching frequency is observed for the Vaska's complex. This clearly indicates that there is a binding of O2 with our complex. This is some such kind of this kind of porphyrin-based macromolecules also employed. So, what is the role of these tertiary butyl groups? They will provide the hydrophobic environment, the amyl groups which are present in the carbons are providing the hydrogen bonding interaction with your bound O2. So, this O2 cannot undergo any further reaction with the nearby heme units, and the dimer formation also prevented in this complex also. Instead of histidine imidazole nitrogen, we will employ the simple methyl imidazole as a monodentate ligand, and this is a porphyrin is a pentatonic ligand. It exhibits the structure as well as function of the hemoglobin and myoglobin also. It's having the O2 binding affinity as well as it releases the O2 whenever we are achieving the experimental conditions. So the bulky substituents as well as the along with your amide functions are highly important for the desired function. Okay, பாப்பா, இதுக்கு அடுத்து வேற இப்போ வரைக்கும் நடத்துனதுல எதுவும் புரியலையா? இல்ல எதுவும் திரும்ப சொல்லணுமா? ஹலோ, இப்போ வரைக்கும் பார்த்ததுல பாத்தீங்கன்னா சிந்தட்டிக் ஆக்சிஜன் கேரியர்ல வந்து 2-3 கோபால்ட் as well as இரிடியம்லாம் பாத்தீங்கன்னா இட்ஸ் நாட் a heme containing active sites மாடல் காம்ப்ளெக்ஸ். இது ஒண்ணே ஒண்ணுதான். இப்போ பார்க்க இந்த இது வந்து பாத்தீங்கன்னா வந்து பிரசன்ட் ஸ்லைட்ல இருக்கிறது வந்து இட்ஸ் a heme containing site. இதுக்கு இங்க வந்து புரோட்டீன் இருக்காது. நம்ம வந்து ஒன்லி என்ன பண்ணுவோம், ஆர்கானிக் மாலிகூல்ஸை வந்து we have to அதுல வந்து அட்டாச் பண்ணிட்டு desired ப்ராப்பர்ட்டி வர மாதிரியும் வந்து we have to synthesize the ligands and then we have to study the property of the complexes in different reactivity. Then next one is the heme erythrin. This is a non-heme ion transporting enzyme. It is a binuclear ion containing enzyme. It is mainly present in the marine invertebrates. It's not present in the higher order animals. It's marine invertebrates mainly containing the heme erythrin. Heme erythrin active site structure is entirely different. So if you are seeing one iron center is a octahedral environment, another iron is in the square pyramidal environment. The octahedral environment of the iron center is constituted by 3 histidine imidazole nitrogen and 3 oxygen atoms. Two is coming from the protein residue carboxylate oxygens. Another one is the hydroxyl ligand. What is the origin of the hydroxyl ligand? The hydroxyl ligand may be derived from the water molecule present in the system. So the 2 carboxylate oxygens, one is coming from the aspartic acid, another one is coming from the glutamic acids. So what is the nature of these carboxylate donors? Carboxylate donor can act as a bridging ligand as well as a terminal ligand also. It can provide only one oxygen bond, coordination bond, or it may give the both oxygen for the bridging also. So one is octahedral, another one is a square pyramidal geometry. The octahedral environment is a coordinatively saturated environment, whereas the square pyramidal environment is not a coordinatively saturated environment. So it is having a vacant site which is available for the small molecule binding. So then again here we can distinguish both oxy and deoxyhemerythrin. If you are seeing oxyhemerythrin, deoxyhemerythrin, 2 iron centers are separated by a distance of 4.5 Armstrong. This is colorless in nature. Iron 2, it does not having any factors,